at NASA, combinations with Johnson Space Center, Goddard Space Center, Space Flight Center, great astronauts, the will of the people, great members of Congress who supported it, said, let's fix it. We fixed other things, and they still work. Old cars still run. Let's make Hubble the better version.
We were all disappointed, but all hopeful that something might be done to save this spectacular space observatory. And in fact, something was done. We had already planned to be doing servicing missions on Hubble over the years, and so the first servicing mission to send astronauts back to Hubble was designed to repair this problem with Hubble.
And this big mirror really was the dominant driver. We worked very, very hard to develop, first of all, how distorted was it? How mispolished was it? And then to find a company in the United States, preferably, that could polish corrective lenses that would take care of the problem. Those two challenges were really immense, and those challenges, when they finally got solved, led to something that was an extremely important payoff to the U.S. and world citizenry.
To fly what you test and test what you fly would be easier if the telescope were back on Earth. But landing and relaunching could contaminate the telescope or damage it through vibration. NASA couldn't test the new corrective optics in the actual telescope. So to make sure the optics will work, the team had to determine the condition of Hubble in space and replicate that on the ground. One independent review panel used Hubble images to determine the precise shape of the flawed primary mirror and the prescription to fix it. Another team had to verify that the corrective optics will work. Teams had to test two optical packages, the replacement wide-field planetary camera and the corrective optics for the other instruments, called COSTAR. Engineers built several independent analyzers to test that they had replicated what the Hubble telescope does to light. For mechanical testing, engineers built a simulator at Goddard Space Flight Center using the same precision equipment that built Hubble originally. To replicate Hubble during electrical tests of the corrective optics package and the new camera, an electrical test facility was built with the same schematics as the original telescope. Hardware has been thoroughly tested on the ground. The Hubble servicing team is preparing for contingencies. But this mission is a first, so no one can predict everything that could happen. The real test will be in space.
5, 4, 3, 2, 1. And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
We copy that, Cubby, and there are smiles galore down here.
They got it.
All right. Fantastic.
I forgot my glove.
Strange.
We're going to do whip pick on day 2 now. Sudden change of
That's it. Change the plan.
No, I think if the arrays are straight, we also have an equal chance that there is no such thing as spherical aberration. The universe is aberrated, and we're going to be correcting for it.
Actually, also that.
Okay, then you're seeing what would be the upper outboard bistem on the plus V2 array. There is a definite kink right at the upper edge of the second panel there, as you can see in the max part of the bend. And it looks like, as the bistems, of course, one is inside the other, it looks like the outer bistem has a kink in it, and it is also twisted approximately 90 plus degrees clockwise there at the kink. Then it looks like it all comes back together within a few feet there of the kink. There's also, probably hard for you all to see, we have to look at with binoculars, a second kink a couple of feet below the obvious one, that is on the back side there of that section of the bi-stem. It's not quite as bad, but it does have a little crease in it.
Foot restraint will be occupied by mission specialist Kathy Thornton. She will be working from the end of the mechanical arm. This television shows Thornton at the array to be jettisoned.
Okay, KT. You ready? Yeah, I'm ready. Okay, they say you got to go for release. Expect 20 pulses on the RHC. Hey, no hands. It is going to be 20 pulses on the RHC for a set burn. Okay. It looks like a burner, Tom. Look at it. Look how stable you left that. There it goes.
Mars observer.
Now you can see
It's like a solar. Look at that. Look at, I've got several places. We identified this pretty late in case something like this happened. So we could go grab blankets and covers.
Maybe if we can have another EVA day like we did the first, and it looks like we're halfway there, we'll be well on our way to having a very, very successfully completed mission. In fact, I remember after the first day saying that if we could just have 2 more like today, we'd be sure of great signs. So it looks great.
The mirror, this is like the mirror in the wide field camera that's used to correct for the spherical aberration in Hubble. And it's done by putting the same error on this mirror that exists on the Hubble mirror, only with the opposite signs. So the result is that after having the optical image distorted by the primary mirror, the distortion is removed by the secondary mirror. And the result is that you get a good clear image at the end.